Let's jump right into this explainer, because today we're unpacking a concept from the world of autonomous logistics that is, honestly, pretty jarring. We're looking at a real, granted patent from Amazon, filed in 2016, granted in 2017, patent US 9828097B1. The official title is Directed Fragmentation for Unmanned Airborne Vehicles. But what does that actually mean? Well, it's basically a blueprint for a delivery drone that is specifically programmed to intentionally dismantle itself and fall apart mid-air. I know, it sounds literally like something out of a sci-fi movie, but as we'll see, there is some profound engineering logic behind it.
So you've got to wonder, why? Why would a giant tech company pour millions into R&D to design an incredibly expensive piece of hardware that's literally programmed to fall to pieces in the sky? It leans heavily into this kind of dystopian mystery, right? Like, you imagine a drone delivering your new toothbrush and suddenly detonating right over your house. But the reality is far more calculated. This isn't about chaos, it's about control.
There's a quote straight from the patent abstract that really nails this. It says, "A controlled, directed fragmentation of the UAV can be accomplished upon any disruption to the flight operation." The absolute key there is in the first three words, controlled, directed fragmentation. This whole wild concept of a self-destructing drone, it's actually a highly calculated, meticulously engineered safety mechanism built for the absolute worst-case scenarios.
Section 1. The danger of free fall.
To really get why this solution makes sense, we have to look at the problem. Delivery drones are out there in the real world, and the real world is messy and unpredictable. According to the patent, a drone could hit severe weather. We're talking high winds, sudden hail, heavy rain, or massive pressure drops. Or what if extreme heat causes the battery to just fail, completely killing the rotor system? A bird strike could knock out flight control. Any of those disruptions instantly turns a perfectly good delivery vehicle into a massive hazard.
Think about what catastrophic failure actually looks like. A heavy commercial delivery drone with a package, big batteries, heavy rotors, a fixed shell. If that loses power, it goes into an unpredictable freefall right over a populated area. That is a huge kinetic impact waiting to happen. So Amazon's radical alternative is directed fragmentation. Instead of one heavy, uncontrolled projectile, the drone rapidly breaks down into smaller, lightweight parts. Those smaller pieces have different aerodynamic drag, way less momentum, and they fall slower and more predictably, which means they're significantly less dangerous. The patent even suggests using tiny parachutes or aerodynamic shapes so these lighter pieces can essentially glide safely to the ground.
Section 2. The Fragmentation Controller.
How does a falling drone actually orchestrate this midair? Well, it uses a dedicated brain. The patent calls it the Fragmentation Controller. It's an independent system on board the drone, acting like an emergency triage director. And independent is the magic word here. This controller operates entirely separate from the main flight computer. It even packs its own backup battery. So if the main power completely dies and the main computer shuts off, this fragmentation controller is still awake, ready to trigger the survival protocol.
And this backup brain is doing an unbelievable amount of math. Even before a failure happens, it's constantly evaluating split-second data in the background. It's monitoring the flight path, speed, and momentum. It's calculating the weather, like wind speed. It tracks the pitch, yaw, and roll of the drone itself. Plus, it's actively analyzing the terrain topology directly below it. It is constantly doing the intense physics calculations required to know exactly where every single piece of the drone will land if it detached right at that exact millisecond.
The way this terrain mapping works is fascinating. The drone's data actively prioritizes the ground below into categories. High priority, meaning safe drop zones, are things like ponds, lakes, and rivers. Medium priority covers open fields and forests. Low priority, the absolute danger zones, are highways, parking lots, and residential neighborhoods. Basically, this controller is always looking down, making sure that if everything goes wrong, it's going to toss the heaviest pieces into a lake or an empty field, actively keeping them far away from people and houses.
Section 3. Mechanisms of mid-air disassembly.
Okay, so the brain knows what to do, but how does a solid piece of machinery physically break itself apart? The patent actually lists some wild release mechanisms hidden inside the drone. Normally, parts might be held together by permanent magnets. To drop a part, it energizes an electromagnet to cancel the magnetic field, letting the component fall. It also mentions spring-loaded latches that forcefully shove parts away so they don't hit each other, or using compressed gas charges. And yes, reading straight from the patent, it even suggests using small explosive charges. I mean, there is a serious irony in using tiny explosions for public safety, right? But from an engineering perspective, it gives you that instant, forceful separation you desperately need during a freefall.
If you want to visualize all this hardware working, think of it like a multi-stage rocket, but in reverse. Instead of shedding weight to blast upward, it's shedding weight to control its descent downward. Or, if you want a nature analogy, it's exactly like a lizard dropping its tail to escape a predator. By ditching a specific component, the drone instantly changes its overall weight and drag, which forces the rest of the structure to slow down or glide in a totally new way.
Section 4. A directed fragmentation sequence.
Let's put the brains and the brawn together and walk through a hypothetical sequence right out of the patent. Say the drone suffers a total engine failure. The fragmentation controller instantly wakes up. Step 1. It triggers a latch, and the heavy payload, the package it's delivering, drops straight into a dense cluster of trees below. Step 2. Just milliseconds later, a small explosive charge fires, blowing the heavy battery pack clear off, sending it tumbling harmlessly into an empty field. Step 3. The lightweight, aerodynamic shell of the drone glides just a little bit further until it drops safely into a local pond.
What is absolutely brilliant here is the dynamic physics at play. Every single time a piece gets dropped, the drone is instantly recalculating the trajectory for everything that's left. When step 1 happens and the package drops, the drone loses a huge chunk of weight. That completely changes its momentum and flight path. The computer factors in that brand new flight path in a split second before executing step 2. That's how it ensures the battery hits the field and the shell actually reaches the pond. It's a cascading sequence of real-time physics happening in a fraction of a second. Just wild.
Section 5. A radical safety solution. Wrapping this all up, it becomes clear that what sounds like total chaos at first is actually incredibly methodical. It all goes back to the core ethos of the patent: alter the manner in which the UAV descends to control the descent in a preferred controlled manner. Now, to be clear, Amazon hasn't actually deployed these self-destructing drones in the real world yet. This was filed back when companies were trying to prove to the FAA that drone delivery over cities could actually be safe. So this patent is really the ultimate theoretical failsafe. The entire goal of these algorithms, terrain maps, and tiny explosives is just pure harm reduction. It's about protecting people on the ground at all costs, even if it means destroying the drone itself.
Which leaves us with a pretty fascinating thought. While competitors like Google Wing were focusing on just slapping simple parachutes onto drones, Amazon was out here exploring if drones should intelligently self-destruct for our safety. It raises some big questions, though, like liability. If a fragment still manages to hit something or someone, who's really responsible? And looking ahead, how will the future of autonomous vehicles, from self-driving trucks to air taxis, handle their inevitable failures? Because this patent proves that the future of engineering isn't just about building things that work perfectly. It's about designing brilliant ways for them to fail gracefully. Thanks for joining me for this explainer. I hope it sparked your curiosity about the invisible engineering happening right over our heads.